Hi everyone. This is the first in a two-part video series on the chi-square test for independence. And the chi-square test for independence is designed to determine if there is a relationship between two qualitative variables. The problem we're going to look at, sort of our context for this, is a 2016 student project in which the student who worked at a movie theater actually gave a survey out asking for an individual's gender and their movie preference. Gender in that case was male or female, and in this study the movie preferences were action, fantasy, so like Lord of the Rings type, comedy, drama, or thriller. And she recorded these data for 282 individuals that came into the theater. Now, the chi-squared test is appropriate in this case because you've got two qualitative variables. You've got preferences, which are the columns, the movie preferences, and gender, which are the rows. All right, now the data, so basically the question you have for a chi-squared is, do the data provide sufficient evidence to indicate whether a moviegoer's preference for movies is related to gender? What that means is there a relationship between gender and movie preference. What that's really asking is, can I make some predictions? If I know something about an individual's gender, for example, am I better able to predict what sort of movie preference they have? So the null hypothesis in a chi-squared is again going to be a skeptic's hypothesis. There is no relationship between gender and movie preference for all individuals. HA rather, is going to be there is a relationship. There is a relationship between gender and movie preference for all individuals. This is a hypothesis test, so we're going to reject H naught if the p-value is less than our level significance alpha. It is a chi-squared test because we're again trying to determine if there's a relationship between two qualitative variables. So the test statistic is chi-squared equals the sum of observed outcomes minus expected outcomes, which we'll talk about in a bit, squared over the expected outcome. All right, the way to conduct the chi-squared test, we'll do it on StatCrunch or any stat package will work. Here are the data. I've got them in. Under Stat, you want to choose Tables and a contingency table. Now, you do not have the data. You do not have individual responses. You go to Summary of the data. So with Summary, remember that the columns that we were investigating were movie preferences, so action, hold the control key down, fantasy, comedy, drama, and thriller. So those are the columns that contain the data, and the rows were the gender and compute. Now, what this data tells you, the chi-squared statistic, the degrees of freedom is the number of rows minus 1, so it's 2 minus 1, times the number of columns minus 1, so 1 times 4 is 4. The 51.99 essentially is the chi-squared test statistic. That's a value, which we'll talk a little bit on how to get that in a sec. But for the test, the p-value is less than 0.0001. So our conclusion, since the p-value which is less than 0.0001, is less than, in our case, level of significance is 0.05, we're going to reject H naught. So we can conclude that there is a relationship between gender and movie preference. For all individuals. What that means is if I tell you something about an individual's gender, you might, in some instances, be able to tell me something about their preference for movies. All right? So that's the chi-squared test. As with all hypothesis tests, tell me the null and alternative, the decision rule, the test statistic, conduct the test on StatCrunch or any stat package, and then write a good conclusion. But now, for the next few minutes, let's dive a little bit deeper into the chi-squared test. Okay, as my dog is shaking his head, he doesn't know if he wants to do that, but we'll do it. We'll do it nonetheless. Okay, the chi-squared test statistic is based upon, so what you do is you look at a difference between what is observed. So you've got what is observed. Those are the data that were given. And in this table, that's the top. So like there were, out of the 282 individuals, 34 males that preferred fantasy movies. Okay? Now, the other thing that we want to look at is what's expected. And what's expected means essentially this. Out of the 282 individuals, 148 were males. That is 148 out of 282 is 52.48%. And they were male. So if there's no relationship in each of these columns among the action movies, 52.48% of the individuals should fall into the male action column. Essentially, if there is no relationship, then each column is going to match the overall totals. Essentially, 52.48% would fall into the male category, and that would be 47.54% of the data in each column should fall into the female. Now, if there is a relationship, then what's observed will be different than what's expected. And the way to calculate the expected amount, so basically you can look at the percentage, like for example, for males, there's a total of 78 action individuals, so individuals that prefer the action genre. For the males, what's expected, it would be 52.48 or 0.5248 times the total amount, which is 78, 40.93. Okay, that's what's expected in males in genre if there's no relationship. Now, there's a quick way to do this, and that is to say that the number that's expected is equal to the total number in a row times the total number in a column divided by the overall total. So see if we get the same result. That would equal 148, the total number in the male row, times 78, the total number in the action column, divided by the grand total of 282. And when you put that in your calculator, you indeed get what is it going to be? Let me go ahead and do it. 148 times 78 divided by 282. 40.936, okay? Or 40.94%. All right, I rounded off here, so it's 0.48 and change actually for males. Do the same thing for females, so we'll change this to a 9.4. For females, the expected amount is the total in the row, female action, which would be 40, excuse me. So this is male action genre. For female action genre, it would be the total in the row, which would be 134 in the female row, times the total in the column, which is 78, divided by the grand total of 282, and that is going to equal 37.06. So, if there was no relationship, then we would expect, if there's no relationship between gender and movie preference, we'd expect about 40 individuals, 40.9 males to prefer action, and 37.06 females to prefer the action genre. Notice that there's quite a difference between what we observed in the cell and what's expected in the cell. And that's where we're going to pick up with in the next video.